Hi all. So here's a quick tutorial on calculating centroids of a complicated object. This came from the 2013 NZDE exam, and I'm happy to say that the problems since then have all been a lot easier. This is one of the hardest problems I could find to take you through the process. This question asks us to find the centroid, and we'll have to do that in both the x axis and the y axis. So we'll be doing two lots of calculation. Now, we could simply do our moments, work our moments from all our objects, and then it's the sum of the moments over the sum of the area. However, as I've discussed in class, I prefer the table method because when you move on, you'll actually start working into your second moment of area values, which continues the table. So let's make a start. As we can see with this object, we have three individual objects. We have the large rectangle, so we'll call that object 1. We have a triangle, we'll call that object 2, and we have a hole, so we'll call that object 3. So we'll start off with our table, and across the top we'll have our description, and in this case I'm actually going to draw them. So we have a rectangle, we have our triangle, and we have our circle. We need to remember that that's a hole, so it's minus, so it's a negative. So the first thing we want to calculate is our area. And again, if you draw the table large, you can actually put your calculations into the area. So for the oblong, we've got breadth times the width, so it's 700 times 350 and 360 is 710. And I'm just going to leave it in millimeters. We could simplify it, move it into centimeters, which make our numbers easier, but that's up to you. So 700 times 710. And I've got 4,907,000. There we go. 497,000 millimeters, and that will be millimeters squared. Moving down to the next object, which is our triangle. Area for a triangle, half base times height, so 0.5 times 120 times 360, and I've got 21,600. Our next stage is our circle, and I'll use pi d squared over 4. So the diameter of the circle, it doesn't give us to give it as on the here the drawing, but it is up there in the question. So pi times 200 squared divided by 4 equals, and I get, rounding it, I'm just going to round it up, so it's 31,416. 31,416. And remember, that's a minus because it's a hole, so it will come out. So our total area, if we add them all up together, and I get 487,184 is my total area. So the next part, we're going to look for the individual centroids of the x, and we take that from our point 0. So the x on a triangle is 1/3 from the base. So we would have 1/3, so that would be 80 and 40, so it would be 80 millimeters from our point. Okay, and oh, that's the triangle, sorry, my mistake. So moving to the square, the rectangle, that would be 350 and 350. So from our datum point, we've got 350 plus 120 is 470. And our circle is on, I'm trusting the circle's on the same point, that's 700 across, so we've got 250, 200 is 450, which would leave 250 on this side, so that's also at the same point as the square, which is 470. So now we can simply AX, so that times that will give us our AX. So 497 123 times 470 equals, and we end up with a very large number, so I'm just going to hit the engineering button, and it's 233.6 times 10 to the 6. Okay, now we'll move on to the triangle. 21,600 times 80 equals, hit the engineering button, I get 1.73 times 10 to the 6. And now we'll move on to our circle, which is 31416 times 470 also equals, hit the engineering button, and I get 14.77 times 10 to the 6. So now we can add all them together and see what our total moment is. Now, bearing in mind that the circle is a minus. So I'll just times that by -1, which gives us the minus. So plus 1.73 exponential 6 plus 233.6 exponential 6 equals, and we end up, hit the engineering button again, 220.56 times 10 to the 6. So now our x centroid will equal the sum of the moments over the sum of the area. So if we go 220.56 divided by times 10 to the 6 divided by 487,184, our x dash equals 452.733. Now we have to look at that and ask ourselves, do we think that's right? So we've got a small area here, and we're taking the whole there, so I'm going to suggest that yes, around about the center is our 452. That looks relatively right, and that's millimeters. So now we're going to move on and we're going to do the y. So now if we look at the y, again we're now looking in the y-axis, so we're moving up and down the object. So looking at the the rectangle first, the centroid is 355, so that gives us 710, so our centroid is actually at 355. 355. Moving next to the triangle, it's 1/3 up. Well, the height here is 360, so 1/3 of 360 is 120. And the circle, if we look to the center of the circle, we've got 360 plus 100 is 460, and another 100 takes us to the center of the circle, gives us 560. So now again we just go through the A, Y. So 497,000 times 355 equals, engineering button, is 176.45, and that's times 10 to the 6. Now we'll move on to the triangle. 21600 times 120 equals, engineering button, and I get 2.60 times 10 to the 6. Now we'll move on to the circle, which is we'll make that a -31416 times 560 equals, hit the engineering button, and I get -17.6 times 10 to the 6. So now we can total that up, plus 2.6 exponential 6 plus 176.45 exponential 6, and we end up with, hit the engineering button, 161.46 times 10 to the 6. So now our y dash equals sum of the moments over the sum of the area, 161.46 times 10 to the 6 divided by our total area, 487,184. So we divide that, 487,184 equals, and we end up with y dash equals 331. Now, does that look right to us? So we're saying that our y dash is around about here, 331. Well, I'd say yes, because that hole there will move the centroid down, and the extra triangle here will move it down as well. So I'm quite happy with that. So there's a quick explanation on how to solve the centroids in a compound shape.